In this video, let's go ahead and apply our understanding of parallel lines and the slopes of parallel lines to find a missing value together. Given that C, which is at x, 16, D, which is at 2, -4, E, which is at -6, 14, and F at -2, 4, let's go ahead and see if we can find the value for x so that this segment CD or line CD is going to be parallel to line EF or segment EF. Doesn't really matter. So one of these lines is going to be CD. So let's go ahead and pair those two together. And for this line, we can call x x1 and 2 x2. And we can call the 16 y1 and the -4 y2. So let's go ahead and take this information and write an equation for the slope of CD. So remember, we use the variable m to represent slope, so this is going to be the slope of line CD. And we can set that equal to this y2 minus y1 over x2 minus x1, or the equation for slope, which is rise over run. Let's go ahead and substitute our values in that we have for line CD. Alright, once we have that substituted in, let's go ahead and clean this up a little bit. If we go ahead and subtract 16 from that -4, we're going to end up with a -20 in the numerator, and we still have this 2 minus x expression in the denominator. At this point, this is going to be the expression that represents the slope for line CD. It's as far as we can go for now. Alright, let's look at line EF now. This one's going to be a little bit easier to deal with since we don't have any variables and we can actually find the slope of this line. Now for this line, the -6 and -2 can be our x1 and x2, and the 14 and 4 can be our y1 and y2. Let's go ahead and use that information to find the slope for line EF now. Alright, so for the slope of line EF, that's going to be equal to the ratio of the change of y to change of x for line EF. So let's go ahead and now just substitute in some values. So using the coordinates we have for line EF, we're going to write. And then if we go ahead and simplify the numerator and denominator, 4 minus the 14 is going to be -10 on top, and then -2 take away -6 is going to be a +4 on bottom. Cleaning this up just a little bit more, we can divide the top and bottom by the GCF of 2 and just say this is going to be -5 over this +2. This is going to be the slope for line EF. Alrighty, so now if these two lines are supposed to be parallel to each other, then the slopes must be equal, right? Since we know that the lines CD and EF are supposed to be parallel to each other, that means their slopes have to be the same. So from that, we can set up the equation and say that this expression of -20 over this 2 minus x must be equal to this -5 over 2. So what we have here is called a proportion, and you can solve them a few different ways, but I think a common way that people like to solve them is by using cross products. So if you have a fraction equal to a fraction or a ratio equal to a ratio, then we can always say that if you multiply the diagonals here, or this cross, this is going to be equal to this cross. So these are called cross products. So from this, we can go ahead and write the equation and say that if we have 2 multiplied by -20, that's one of the cross products, that has to be equal to the other cross product of -5 multiplied by the quantity of this 2 minus x. Now on the left side, 2 times -20, that's going to be -40. So we're going to write -40. And then on the right side, let's go ahead and distribute this -5 to this 2 and to this -x. So -5 times 2 is going to be -10. And then if we go ahead and take this -5 times -x, that's going to be a +5x. At this point, we just have a two-step equation. And we can go ahead and add 10 to both sides, so we get -30 on the left side, and we're going to get this +5x on the right side. And then finally, if we go ahead and divide both sides by 5 here, we're going to get that x is going to be equal to -6. So what we found right here is the value for x has to equal -6 for line CD to be parallel to line EF. Now, just for good measure, let's go ahead and look at this on a coordinate plane to see if it makes sense. Alright, so we're saying that x is going to equal -6, so let's go ahead and just see what our coordinates were. So we're saying that this is going to be a -6, that's for point C. Alright, so let's look at our 4 points and let's put that on the coordinate plane here. So I think what I'm going to do here is, because we have some numbers larger than 10 and my coordinate plane only goes up to 10, let's say everything on the x-axis is going to represent 2, so I'm saying times 2, and everything on the y-axis is going to be, every box is worth 2, so I'm going to say times 2 as well. So for that first point for C, we have -6, 16. That's going to be 2, 4, 6, 3 boxes to the left of the origin, and then +16 is going to be 8 up. So 1, 2, 3, 4, 5, 6, 7, 8. So right here would be this -6, 16, and that's going to be point C. Now point D is going to be at 2 comma negative 4, but remember every box is worth 2 here, so 2 just means really going 1 box to the right, and a negative 4 means 2 boxes down, since it's going to be 2 times negative 2 is negative 4, so we're going to be down here in quadrant 4, and that's going to be D. So this right here would be the line segment CD, or you can extend it to make a line if you wanted to. Now if you look at E, E is at negative 6 comma 14, so negative 6 would mean start at the origin and go 3 boxes to the left, and then we're going to go 14 up, but in this case we're going to go 7 up, because everything's worth 2. So 1, 2, 3, 4, 5, 6, 7, that's going to be right here. So it's actually very close here, but that's going to be point E. And then finally, point F is going to be at negative 2 comma 4. So negative 2 is going to be 1 box to the left of the origin, and then it's going to be 2 boxes up. So that's going to be right here. This is going to be point F. All right, so connecting points E and F, we can see that these two lines are indeed parallel to each other. All right, so basically what we did was we set up an equation to find the slope for CD, then we set up another equation to find the slope of EF, and because the lines are parallel, we set them equal to each other. When we set them equal to each other, we have something called a proportion, where a fraction is equal to another fraction, or ratio is equal to another ratio, and you can use cross products and multiply the diagonals to set up an equation to go ahead and solve for x. So hopefully you found the video helpful. If you did, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.